All right, hi folks, this is Larry Mussolino. I'm recording a video for MATH022. This is on Objective 14. And if you notice, there's only a handful of topics here, and these all have to do with division problems. So we're going to be dividing polynomials. We'll do long division and also something called synthetic division. All right, so let's get started. Let's do a few examples here. By the way, I want to remind you about the reference packet. So I'm going to keep this reference packet handy. Let's use one of these topics right here, changing an improper fraction to a mixed number. In fact, why don't we go do that topic right now? So notice here it says writing an improper fraction as a mixed number. All right, so here it's given to us as 24/7. Now, one thing to remember is when you see the fraction bar, it really means division. So really, this is 24 divided by 7. So what you do is you ask yourself, how many times does 7 divide into 24? Well, that's 3 times, right? 24 divided by 7 is equal to 3. But 3 times 7 is 21. So that means there's a remainder of 3. So what you do is you put the remainder over the original bottom number. So if we have 24/7, there's going to be a whole number answer. Then there's going to be the remainder. So I'm going to put another fraction here. This box is going to be the remainder. And this box here on the bottom is going to be the original denominator that you started with. Well, the original denominator we started with is 7. And when I work out 24 divided by 3, the whole number part of it is 3. But 3 times 7 is 21. That means there's a remainder of 3. So I would write this as 3 3/7 as the answer. All right, let's do another one of those. Let's do another. All right, this one says 35 divided by 9. All right, so 35 divided by 9. The way I'm going to set this up as a mixed number is put the whole number part here, then set up a fraction. The top of the fraction here is going to be the remainder, and the bottom of the fraction is going to be the original denominator. Well, I know the original denominator is 9, so I can put that in right away. All right, well, how many times does 9 divide into 35? Well, I know that 9 times 4 is 36. That's too big. 9 times 3 is 27. So 9 divides into 35 3 times, but there's a remainder. 27 leaves me a remainder of 8. So the remainder is 8. So I'm going to put an 8 on top. Okay. And also remember, folks, you have this explanation. So if I come over here to the explanation, it's going to show you that when you do this division, they're doing kind of a long division. 3 times 9 is 27. That leaves 8 as the remainder. So you put the remainder on top, the whole number answer here in front, and the original denominator on the bottom. All right, let's go to another topic. All right, this one's asking you to come up with the quotient and the remainder. So when they say the quotient, they really mean the whole number answer when you do the division. So one way to think about this is do long division. If you remember long division, you put the first number underneath the division symbol, you put the second number out in front. And then you say to yourself, how many times can 5 divide into 2? Well, 5 can't divide into 2. So then I move over and say, how many times can 5 divide into 27? Well, I know that's 5 times. 5 times 5 is 25. You write the answer underneath and subtract. Well, if I subtract this, 7 subtract 5 is a 2, and I bring the 6 down. Now 5 divides into 26, again, 5 times. 5 times 5 is 25, subtract 1. This number you end up with here is what's left over, so that's the remainder. The quotient is this number on top, 55. So the answer to this problem is the quotient is 55 and the remainder is 1. Okay, and of course, remember, if you wanted to, you could go to the explanation and they would show you the step-by-step worked out long division process. They came up with a quotient of 55 and the remainder of 1. All right, let's come here about simplifying fractions. Well, here's what we're going to end up doing. When we have a fraction like this, 7xyz over 49z, I'm going to think of this in 2 ways. First, I'm going to work with the numbers only. Then I'll work with the letters. Well, I have 7 over 49. Well, I recognize that this fraction can be simplified because 7 can divide top and bottom. Well, if I do that, I'm going to end up with 7 divided by 7. That's a 1 on top. 49 divided by 7 is 7 on the bottom. So the numeric part of this works out to be 1 over 7. Now let me look at the letters. Well, there's a z on top and a z on the bottom. Well, really, you could think of those as canceling out. So that leaves me just an x and a y on top. Now, usually we don't put this number 1 in front. You could leave the number 1 in front there, but usually we leave it out. So we would just write this as x, y over 7 as the final answer. Okay, so think of this in 2 parts. One part is simplify the numeric part and then simplify the letter or variable part. All right, let's do another example like that. All right, so here's an example where it's asking me to divide a polynomial on top by a monomial. A monomial just means one term. A polynomial means many terms. Now, sometimes this is a little easier to write this as a fraction. So I'm going to write this as a fraction. Remember, the division symbol really is a fraction bar. So I can write it as, instead of using the division divided by -3u, I could put the -3u on the bottom like this. All right, well, there's a way to break this up into 3 separate fractions. The way I can do this is take each part of the top and put it separately over the bottom fraction. So I can break this up into 3 separate fractions. So I could take 27u to the 3, put that over the denominator, then separately put 21u to the 2 over the denominator, and 9u over -3u in the denominator. Now I can simplify these fractions separately. All right, let me come over here. 27 divided by -3, that's a -9. And then I have u to the 3 on top and a u to the 1 on the bottom. Well, you might remember there's a quotient rule that says when you have an exponent on top and an exponent on the bottom, a fraction, this is where you subtract the exponents. So I'm going to subtract the exponents. 3 subtract 1 is a 2, so that's going to be u to the 2. All right, let me go to the next fraction. 21 divided by -3 is a -7. And I have u to the 2 over u to the 1. Well, here's where I subtract fractions. That's going to leave me a u to the 1. And finally, in the back, 9 divided by -3 is a -3. And u over u really just cancels out. So here is the final answer. This answer is okay to enter in ALEKS. If you want to, anytime you add a negative number, it's the same as subtracting. So another way I could write this answer is -9u to the 2 minus 7u minus 3. That answer would be okay as well. All right, so the key to this problem was really think about setting up a fraction, but then you can separate this into 3 separate fractions so you can simplify each fraction individually. All right, let's do another example. All right. Well, this is the same kind of setup. The only thing that's a little different is there's two variables. There's two letters here, U and Z. Well, the first thing I'm going to do is write this as a fraction, because I know when I see a division symbol like that, I can really change it to be a fraction bar. So I'm going to put 3 U to the 4 Z to the 2 on the bottom. Now I'm going to separate this into 3 fractions. I'm going to take this top part, negative 6 U to the 5 Z to the 7, and put it over the denominator. Then I'm going to take this next term on the top, put that over the same denominator. And finally, I'll take this third part and put that over the denominator as well. All right. Let me remind you, we're going to use this quotient rule again. It says if you have a base on top and the same base on bottom, you keep the base the same and you subtract the exponents like that. All right, let's start in the first fraction. Well, for the first fraction, I have a negative 6 divided by 3. That's negative 2. Now I'm going to work with the u's here. I have u to the 5 over u to the 4, but that's where I'm going to subtract the fractions. 5 subtract 4 is 1. Then I have z to the 7 over z to the 2. Subtract the fractions. 7 subtract 2 is a 5. Let me move to the next fraction. 15 divided by 3 is a 5. I have a u to the 4 over u to the 4. Well, you can either think of those as canceling out because they're the exact same quantity, or you can think of it as u to the 0. Because remember, you keep the base the same and subtract the exponents. The same thing for the z's. I could either just cancel them out or write it as z to the 0. But remember, any quantity to the exponent 0 is 1. So this is really just going to be a 1, and that's going to be a 1. So it's easier just to cancel these out. Let me go to the back fraction. 12 divided by 3 is 4. All right, here I have u to the 2 subtract 4, but that's negative 2. And last here for z's, keep the z, subtract the fractions. 7 subtract 2 is a 5. The only other thing I could do here is get rid of negative exponents. So here's what I have. Negative 2 u z to the 5 plus 5 in the middle plus 4 z to the 5. And you remember, to get rid of a negative exponent, move it down to the denominator. So I'm going to move it down to the bottom of the fraction, and you flip the exponent to be a positive value. Okay. So again, what we did here is we took the problem, wrote it as a fraction, then separated into individual 3 separate fractions, and then simplified each fraction individually. All right, let's come here to an example that's called long division. Now, long division, this is a little messy, so I want to go here to this explanation. And please read through this explanation, because this will give you a good detailed step-by-step. But let me try to do it also here. All right, well, for long division, what you do is you take this first expression and put it under the fraction bar. And you take the second expression and put it out in front. All right, now we're going to do long division similar to the way you do long division for numbers. All right, here's what I'd like to do. I'd like to cancel out this 2x squared. So what I'm going to ask myself is what quantity times this x in front here results in 2x squared? Well, I know the answer to that is 2x, because if I take x times 2x, I get 2x squared. So I'm looking for this quantity 2x. I'm going to write that up on top here, 2x. Now I'm going to take this 2x and multiply it times x. That's 2x squared. I'll write that underneath here. But I'm also going to take this 2x and multiply it by 5. That's 10x. I'll write it here. Now what you do is you subtract this bottom expression. When you subtract a parenthesis like this, you're really going to change the sign of each expression inside. So what I'm going to do is I'm going to make this a minus and that a minus. Remember, we were subtracting 2x squared plus 10x. But when I do that, I end up with negative 2x squared minus 10x. Right? It's almost like you're distributing that negative sign inside the parentheses. All right, now I'm going to add straight down. Well, 2x squared and negative 2x squared, those cancel out. That's what I wanted to do in the first place. Then I have a 17x minus 10x. That's 7x. And I'm going to copy this 30 down with me. All right, now I do the same process. I want to cancel out this 7x. So I'm going to look here at this x and ask myself, what quantity times that x in front results in the 7x I want to cancel out? Well, the answer to that is 7. So I'm going to put a 7 up here on top. 7 times x is going to be the 7x, and 7 times 5 is 35. So I'm going to write that underneath here. But then what you do is subtract. But when you subtract, you're really changing the sign of each quantity inside the parentheses. So I'm going to change this to be a minus and a minus. Now I'm going to add straight down. The plus 7x and minus 7x cancel out. And when I add plus 30 and negative 35 here, I get a negative 5. Well, this negative 5 down here is what's left over. We call that the remainder. The quotient is what's sitting up here on top, 2x plus 7. So this problem is going to ask you for the quotient. In our example, it was 2x plus 7. And it's going to ask you for the remainder. In our example, the remainder was on the bottom there, the negative 5. So this is called long division. And again, if you come up here and click on the explanation, it'll show you the step-by-step details. All right, let's do one last topic. And the last topic here is called synthetic division. Now, synthetic division is a way to do that long division we just did, but in a more streamlined way. So let me show you the setup here. What they're asking me to do is come up with the quotient and the remainder. So the quotient is going to go in this box. And the remainder is going to come up here on this box. Now, I could do this using long division, which is the method we just did a minute ago, or I can use synthetic division. All right, here's the way synthetic division works. Now, they've already set this up for me in this setup. I'm going to write this over here just so I have a little more room to write this out. So let me write this out. Here is the setup they're giving me. -2 in front, and then they put -1, 2, 12, 0, and -60. You might say, well, where'd they come up with these numbers from? Well, here's the -1, here's the +2, here's the +12. There's really an x missing, so they put 0x, and then here's the -16. But they gave me all these numbers. All right, so here's what they're asking me to do. They're asking me to fill in these boxes. All right, let me explain how to fill in these boxes. And once we do that, we'll be able to come up with the answer that they're looking for the quotient and the remainder, okay? And just to let you know ahead of time, whatever number shows up in this box, in this bottom box, is going to be the remainder. And then these boxes here are going to tell you about the quotient. All right, but how do we fill in these boxes? All right, well, here's the way you do it. First thing you do is you copy this first number straight down. So you don't do anything with this -1 except copy it straight down. All right, now what you do is we want to fill in this box next. What you do is you take this number in front, -2, multiply it by this number down here, -1, and write the answer in this box. Well, -2 times -1 is +2. Now, what you do is you add these numbers straight down. 2 plus 2 is 4. So I put a 4 in that box. And now I do the same procedure over again. I take this -2 in front, multiply the 4, and put the answer in this box. All right, well, -2 times 4 is -8. So I'm going to put a -8 in that box. Now I add straight down. 12 plus -8 is a 4 again. All right, I'm going to do this all over again. -2 multiplies 4, and I'm going to put the answer here. That answer is -8. Add straight down. 0 plus -8 is -8. All right, one more time. -2 multiplies -8. That's +16. Write the answer in this box and add straight down. Well, -16 and +16 is 0. So it turns out in this example, the remainder is 0. Now, in other examples, the remainder might be 3. The remainder might be -5. Right? It's just a coincidence that this remainder turned out to be 0. All right, so we know the remainder is a 0. So I'm going to put a 0 up in this box. All right, now what we have to do is interpret the quotient. Well, the quotient is given by these blue boxes right here. All right, now here's the way you do it. This -1 is the coefficient to put in front of x to the third. So I'm going to put this as -1 x to the third. This 4 is the coefficient to put in front of x squared. This 4 is the coefficient to put in front of x. And this is the constant -8. And we know the remainder is 0. So these numbers that you end up with for the quotient are the coefficients, the numbers to put in front of x. Now, how did I know to start with x to the 3 here? Well, our original problem started with x to the 4, but we're dividing it by x. So when you work out x to the 4 divided by x, you get an x to the 3. So this exponent here is always going to be 1 less than the exponent you started with. If I started with x to the 4, this coefficient here is going to be x to the 3. And then you just go down 1. Then this is x to the 2, x to the 1, and the constant. Okay, and again, folks, if you check out the explanation, it'll also show you the step-by-step of this synthetic division. This is a little tricky, and you got to practice this to kind of get the flow of how these steps work. All right, folks, hope this is helpful as you're working in this objective 13. Excuse me, objective 14.